So when we differentiate implicitly, we're looking for dy dx. And the way we read that is the derivative of y with respect to x. So remember that we're respecting x. But now there's two different variables. We're respecting x, so we're not respecting y. So anytime we differentiate y, we're going to put a dy dx, a factor of dy dx, beside it, okay? For instance, y to the sixth up here, its derivative is 6y, and it gets a factor of dy dx because I differentiated the variable y, and I'm not respecting y, I'm respecting x. But x cubed, its derivative is 3x squared, and it does not get a dy dx beside it since I'm respecting x. Equals 2y, it gets a factor of dy dx beside it. Again, because we're not respecting y, we're only respecting x, plus 9. So from here, what I want to do is get everything that has dy dx on one side and everything else on the other side of the equal sign. So 6y dy dx is going to stay on that left side. I'm going to bring over the 2y. And on that right side, 9 stays there, and I'm going to bring over the 3x squared. From here, I want to factor out a dy dx on that left side, and I'm left with, if I take a dy dx away from 6y and 2y, I'm left with 6y minus 2y, which is really 4y. And let me make that look a little better. So now what I want to do is I want to solve for dy dx. So just divide by what you don't want. I don't want 4y. I just want dy dx. And we get that our derivative equals 9 minus 3x over 4y. So to find the slope at the point 0, 1, you find the derivative and plug your point into that derivative. So we're used to only using the x value of that point to plug in the derivative, but with implicit differentiation, our derivative has both an x and a y value, so we can plug both of those into our derivative. So the x was 0, the y was 1. So we end up getting 9 over 4 as our slope.